Hi, I'm Miss Hall, and this is lesson 0.2, Function Features. In this lesson, we're going to review intercepts, end behavior, turning point, intervals, and symmetry. We begin with intercept. So you've probably heard of x-intercept and y-intercept. These are points where the graph crosses either the x-axis or the y-axis. On graph number 1, this graph has 3 x-intercepts. 3 points where the graph crosses the x-axis. So I'm going to change that to x-intercepts. And graph number 2 has 0 x-intercepts. It never crosses the x-axis. If we look at both of these graphs in regards to y-intercepts, we'll see that graph 1 has 1 y-intercept. It's also an x-intercept. And that graph 2 has 1 y-intercept. Now on to end behavior. End behavior describes how the function behaves at the ends of each of the x-axis. So in graph number 1, it says when comparing the two graphs, they have the same end behavior. Because that's at the end of each graph, both sides are going up. And in graph 2, it says when comparing these two graphs, the graphs have different end behavior. And that's because the first graph, the ends are going in the same direction, in this case down. And in the second one, down, up. So we read a graph from left to right. So for example, for this graph, we could say that the end behavior is down and then up. So first we describe the leftmost behavior and then the rightmost behavior. Now on to turning point. A turning point is where the graph changes direction. In graph number 1, there are 3 turning points. And their turning points we could label their x, y. So for example, 2, 3, this is -3, 0 is one of the turning points. In graph number 2, there is a single turning point. This one, for example, is 3, -1. On to intervals. So an interval for increasing or decreasing is where the graph is either increasing as you go from left to right or decreasing. So increasing would be if the graph is going up. So this is an example of increasing. And decreasing would be if the graph is going down. Now in graph number 1, the graph starts, as you're reading it like a book from left to right, by decreasing. So the graph is decreasing when x is less than 3. And x being 3 is this line. So up until you hit that line, the graph is decreasing, and then the graph starts increasing. Graph number 2 has several times where it changes from increasing to decreasing. And you might notice that I'm actually drawing a vertical line through the turning points where the graph changes direction. So this graph is increasing when x is less than 2. Okay, so here's where it's increasing. From 3 to 5, so when x is between 3 and 5, it's increasing. And above 7, great. We use a different color for decreasing. It's decreasing between 2 and 3, and 5 and 7. The final function feature we're going to review is symmetry and where there might be symmetry in a graph. In graph 1, this graph is symmetrical over the line x equals 3. x equals 3 is a vertical line. And at that vertical line, you could flow the graph onto itself. That's why it's symmetric about that line, x equals 3. If you look at graph 2, this graph does not have any lines of symmetry. There's no line we could draw anywhere where you could fold the graph on that line and it would fold onto itself. We'll begin with identifying the number of x-intercepts. There are 1, 2, 3 x-intercepts. The number of y-intercepts, we have 1 y-intercept. Identify the turning points, so we're going to list the points. We have -2, -4, and 2, 4. Describe the end behavior. So I'm going to say this graph is up, then down. So where is the graph increasing? I'm looking for spots where the graph looks like that, and I see here. It's increasing between, so there's many ways to write this. I'm going to put between -2 and 2. Decreasing, looking for spots where the graph is going like that. So it is decreasing when x is less than -2 and when x is greater than +2.